Ever wanted to create your own bidding system where there's something on the line and people can bid for it? No worries, today I'm gonna teach you how you can build your own bidding system using Solidity. Hello everybody, I'm Saion Gupta, founder at 10x Coder Kids, and let's get started. So guys, let's get started. We have given our SPDX license identifier. We have given our pragma that is defining what the version of Solidity we are gonna use. Next, we have given our contract simple auction. We have named our contract simple auction, and we have two variables: beneficiary and auction end time. The beneficiary is the person who has put up some item and for which people are gonna bid, right? And this will be a public variable. It is payable, meaning that we can add balance to the beneficiary, right? So like we can add ether to the beneficiary's address, right? So like if it is, this is the beneficiary over here, we are allowed to add ether to this give ether to this address, right? Next we have public auction end time. So there are two ways how we through which we can specify the end time. One is the Unix timestamps, right? So second since 1970 0101. This is an absolute Unix timestamp we can use, or we can use time periods in seconds. So we're gonna use time periods in seconds right now. Pretty cool. Everything is gonna make sense further in the code. Next we have address public highest bidder and what is the highest bid. Pretty simple to understand. Next we have a mapping from address to unsigned integer, and that is pending returns. Meaning that for example somebody bid for 10 ether, like so he gave 10 ether. Then somebody else said I'm bidding 20 ether, right? Somebody else said I'm bidding I'm willing to give 20 ether. So that 10 ether person will now be now in pending returns. Whoever bid for 10 ether, that address we said that his pending returns are 10 ether, so we need to return him 10 ether because he bid that much amount, but his bid was beaten by someone else's bid, so his ether, that much that he bid, 10 ether, should be returned back to him, right? Next we have bool ended. This will tell if our session has ended for bidding or not, our auction has ended or not. It will be true when the auction is ended, it will be false when the auction hasn't ended. Next we have these events over here, right? So this events, one is highest bid increased and auction ended, and these event highest bid increased will get a bidder and the amount, and auction ended will get the winner and the amount. So over here these two events will be emitted, right? And these we are just declaring events: highest bid increased and auction ended, that are taking in two arguments, but these events will be emitted further in the program. Next we have some errors that will describe failures, and you notice these triple slash comments. These are important over here. So the triple slash comments are also are so called NatSpec comments. So these are called NatSpec comments. They will be shown when the user is asked to confirm a transaction or when an error is displayed. So like when this auction already ended, error will be displayed, then this NatSpec comment will be displayed with it. If bid not high enough will be called, the error will be called, then there is already a higher or equal bid will be shown to us. So on, these NatSpec comments come in hand. So when this error will take place, then this NatSpec comment will be shown. When this error will take place, this NatSpec comment will be shown. When this error will take place, this one will be shown, and when this one will take place, then this one will be shown. So we are defining four errors and four NatSpec comments, one for each. One is auction already ended. So we will call this error when we will find that the auction has already ended, right? So right now we are just defining errors. We'll just call them afterwards in the program. So but if this error is called, then the auction has already ended will be shown. When bid is not high enough and this error will be called, then it will show there is already a higher or equal bid. When it will emit the error auction not yet ended, then we'll show the auction has not ended yet. Finally, the function auction end has already been called, right? And this will be shown when auction end or will already have been called, right? So pretty cool. Next we have a constructor. Over here we were doing all the definitions. Now we are moving on to the constructor. This will take in two things: bidding time, that how long will the bid go, and who is the beneficiary, who is putting up something for which people will bid, right? And we'll just set beneficiary as the beneficiary address that we'll get, and the auction end time as a block.timestamp. So where in whichever block this transaction will be added plus the bidding time. So create a simple auction with bidding time seconds, bidding time on behalf of the beneficiary address. Pretty cool. Next we have function bid. This can be accessed by other contracts also, and we have given payable, meaning that in this we can pay somebody else, right? So in this function we can give ether to some other address, right? So this it is describing this also. Bid on the auction with the value sent together with this transaction. The value will not be refunded if the auction is not won. So this is saying that we'll bid on the auction with the value sent together with this transaction. The value that we sent will not be refunded if auction is not won. So over here we have this is externals, and payable we are giving that we can pay somebody else using this contract, this method. So let's see this. No arguments are necessary. All information is already part of the transaction. The keyword payable is required for the function to be able to receive ether. Revert the call if the bidding period is over. So if the auction has ended, we'll just revert this call, and call we'll call the error auction already ended. If the bid is not higher, send the money back. So the revert statement will revert all changes in this function execution, including it having received the money. So over here we are checking if the value that was sent. So if whatever value we give over here, whatever that was sent, if that is less than or equals to the highest bid, then revert this and say bid not high enough, and give it the highest bid. Show the highest bid. Then we are checking if the highest bid is not equals to 0, right? So if the highest bid that is there already is not equals to 0, then we'll add in pending returns the highest bidder. For the highest bidder, for the previous highest bidder, we'll add in the pending returns highest bid, right? So we are adding the highest bid in pending returns for the highest bidder, the previous highest bidder, because now, like, he bid it for 10 ether, he gave 10 ether, but now somebody else gave 20 ether, so now his 10 ether should be returned back to him, right? So next we are doing that highest bidder equals message dot sender. So whoever made this transaction now is the highest bidder, and whatever value he gave over here, that is the highest bid. And then we'll emit highest bid increase, and we'll say message dot sender and message dot value. So now this is our event that we declared, right? So this is the event that is being emitted that we declare. So we are emitting that the highest bid is increased, and we are telling who is now the highest bidder and what is the highest bid. Now we also have a withdraw method. So for example, I bid 10 ether, I give 10 ether, and somebody else give 20 ether. Now that 10 ether is added into pending returns, and there needs to be some way for me to get back those 10 ether that I bidded before. So that we'll do using the withdraw method. So what we have over here, we have our amount variable that will save pending returns message dot sender. So whatever pending returns for us are for the person who called this method. So we are calling withdraw. That means we want to withdraw, get our pending returns, right? So what we'll do, we'll say pending returns and message dot sender. So we'll save the amount in our amount variable, that how much needs to be returned, save it in the amount variable. Next we are checking if the pending returns is greater than 0. So if it is not 0, it is greater than 0, then what we'll do pending returns message.sender equals 0. Why is this so important? It is important to set this to 0 because the recipient can call this function again as part of the receiving call before send returns. So what will happen, to put this into perspective, what we have, for example, I would call the withdraw method. The money has not been already sent to me, and it is still in the pending returns that 10 ether are left to give to me. So what I can do, I can call withdraw once again before the money is sent to me. So now I'll get 20, and I can call withdraw again and again, and I can call as many times as I want to, right? So what will happen if I call withdraw, I'll get that much money, and from the contract I'll keep on getting money. That should not be allowed. So once we figure out that the amount is greater than 0, right? So once we figure out that there is some amount that is needed to give back to our to the person who wants to withdraw, then we'll just set 0 first. Before trying to give him back the money, we'll just set it to 0. So if he tries to call withdraw once again, it should be already 0, right? So the amount now for him will already be 0, and it will go outside, it will not go in the if statement only, right? And after setting to 0, we'll check if payable message.sender, right? So we'll convert this to a payable, right? So we'll convert this address into a payable address dot send, right, amount. So whatever, we'll try to send it, right? If it is able to if it is not able to send, right? So if it is not able to send, meaning if this returns false, that will be converted to true, and it will go into the if statement, right? And it will say pending returns. It will once again add into the pending returns about the message or sender the amount. So we will not able to return him, so in the pending returns we just added his amount once again, right? That he can withdraw afterwards because we were not able to return for any reason. If we are not able to return, and we'll just return false, else we come here and we'll just return true, right? If it was everything was successful, we'll just return true. Final method, we have auction end. So end the auction and send the highest bid to the beneficiary. This is the auction end method. So it is a good guideline to structure functions that interact with other contracts. They call functions or send ether into 3 phases, right? So checking conditions, performing actions, potentially changing conditions, and interchanging with other contracts. If these phases are mixed up, the other contract could call back into the current contract and modify the state or cause effects, ether payout, to be performed multiple times. If functions called internally include called internally include interaction with external contracts, they also have to be considered interaction with external contacts. So we need to be very careful when we create a method that external, right? Because other contracts can misuse the method also. So first we have the conditions over here. If block.timestamp is less than auction end time, right? And so if it is this, then revert auction not yet ended, right? And if it is ended, if ended, then revert auction end already called. So if we want that it should not be already ended also, right? Ended should not be true also, and it should not be it should not be going on. So if we are making sure that the auction is still not going on, and this is the first time we are calling auction end. So next we'll give effects. So and we'll set ended is equal to true, and we'll emit auction ended, and we'll tell who was the highest bidder and what was the highest bid. And next we'll have interaction, and we'll say beneficiary dot transfer highest bid. So transfer the highest bid to the beneficiary. Pretty cool. Now let's run this program. So what we'll have, we'll first, to the constructor we have to give two things: bidding time, that will be in seconds, and then we'll have to give the beneficiary address. Bidding time will give 20 seconds, and the I'll just give 200, so we have enough time, right? And then beneficiary address is the current address, so the current address is the beneficiary. So if I transact this, now it was successful. Over here it is telling it was successful, right? And transaction mine and execution succeeded, right? And transaction hash is this: from someone, from this address, to simple auction dot constructor, gas is this much, that was cost, transaction cost is this much, execution cost is this much, and input is this much. Decoded input is bidding time 200, and beneficiary address this. Decoded output nothing, logs nothing, val 0 way. Now let's go on to somebody else's account, and if we check this, we can see a lot of things. Let's see who is the highest bidder. It is 0x000 because no bid was placed. What is the highest bid? It is 0. Who is the beneficiary? It is the 0x5b38 address, right? That we gave in the as the beneficiary, right? We'll see what is the auction end time, and it is this in seconds, right? So it is this in seconds over here, right? Next what we'll do, so next what we are gonna do, we'll not withdraw, we'll just bid. So what we'll see, we'll enter the value that we want to give, 10 ether, and then we'll bid 10 ether. So it is saying that we successfully bid, transaction mine and execution succeed. Transaction hash is this: from this to simple auction dot bid, gas is this much, transaction cost this much, execution cost this much, input 0x199 something something something, decoded input empty brackets, decoded output empty brackets, logs from this portion, from this topic is this, and event is the highest bid is increased. The arguments were our address, right? And then this is 9 over here something. Okay, so it is 9 something. Bidder is this address, and amount is 9. So I've given 10 value, that means like it has given 9 because it starts from 0. So if I give 10, then 9 has gone, right? Pretty cool, right? So next what we are gonna do, we will try to with so somebody else will vote now, somebody else will bid. So now this person will bid 9. This person will say 9, right? So now if he tries to bid 9, you will see we get an error that it is saying transaction failed. Why? Because bid not high enough. Pretty cool, right? So what we are gonna do, we're gonna say that bid 11. So this should work, right? So it works. So now the highest bid, if we check the highest bid, it is 11, and the highest bidder is ourselves, this current address. Now if I go over here, and now I will withdraw my money because somebody has beaten my bid, so I'll withdraw my money, and that money has come back to my account, right? That much ether came back to my account, right? So pretty cool. Let's read this and let's see. Okay, so there's nothing over here, and we'll just say that so now that much money came back to us, and we'll say transaction hash is this: from this person to simple auction dot withdraw, gas this much, transaction cost this much, execution cost this much, input this, decoded input this, decoded output bool is true, 0 bool true, and logs is nothing, value is 0 way. And we'll call auction end now. So now you will see that when the auction has ended, right, so now the auction has ended, right, so because the auction time must have been ran out, we call auction end. So now if I go to the benefic, okay, so let's read this logs from this topic this. So let's read the arguments. 0 argument this, 1 11 this, winner is this, and the amount that won was 11 ether. Now I go back over here. So you I don't, okay, so the amount that won was 11 ether, and now this beneficiary should now have 11 ether, right? Highest bid was 11 and highest bidder was this person, and when the auction ended, I think this is in ways, right? I have selected the value should be in ways. I didn't select it should be in ether. I selected it should be in ways, right? So pretty cool. Now we were transacting in ways, right? The transaction that was happening was in ways. I didn't realize it, but I realized it now. You could also have done the auction in ethers, in GWay, in Finny, and all these other currencies. We did the auction in ways, that's why I could not see any change in this number, right? But there was a change in these numbers over here, right? So you can also test this out, but in ethers, right? But as you can see, this is a perfectly working bidding contract. I hope you guys liked the video. If you did, please don't forget to smash the like button and share this video with as many people as you can. Thank you guys, bye, stay safe, stay healthy, and keep watching my videos.